So let's look at the next aspect of motion, speed. What is speed? It is rate of change of distance with respect to time. Here, we will not be considering any kind of direction. Now, is speed a scalar or vector quantity? Obviously, it's scalar because I just mentioned that there's no direction, right? We just discussed that there's no directional aspect. Next thing is dimension. So dimension, my request is always write in an organized manner. So we have dimension calculation. Now for that, we have speed. Just me. Okay. Speed is equal to distance by time. That's the first thing that we need to make a note of. Then dimension of speed is equal to dimension of distance by time. What is dimension of distance? Right, we have length and time is represented by t. So if I rearrange all of this, this is 1 and this is 1 and t to the power of minus 1, and also can be rewritten as m to the power of 0, L to the power of 1, t to the power of minus 1. So that is your dimension of speed. Okay, all this should be simple for you guys by now. Now, types of speed. We have uniform speed, variable speed, average speed, and instantaneous speed. So what does the word uniform mean? Uniform, you guys know, it is same, right? We wear uniform to schools. So you have uniform speed as something like this, right? Plain old, simple, straightforward scenario. This would be a case of, is this uniform? Clearly no, right? We started off slow and it's speeding up. So this is non-uniform. So this is variable speed. So uniform speed is wherein we're covering equal distance in equal interval of time. Variable speed is unequal distance in equal interval of time. Please note that this scenarios, I am showing us just a object moving along a straight line. But when it comes to speed, the direction can be any. If the speed is maintained, even then it's uniform speed. Let me put it this way. If we have an object, so I'm now discussing uniform speed. If I have an object, moving in circular manner or almost circular, or it doesn't matter, whatever manner. So random path. And by the way, but covers say 10 centimeter, say it's a toy, per second. It's able to cover 10 centimeter per second. This is an example of uniform speed. It doesn't matter that it's taking a circular path. It doesn't matter if it's changing the direction. Nothing matters. So if it's moving this way, it is said to be in uniform speed. Okay, that is one thing that you have to keep in mind, that the direction will not matter. This is not a variable speed scenario. This is not a variable speed scenario. This can be a variable velocity scenario, varying velocity scenario. Okay. Next, the concept of average. So what is average in mathematics? What is average in mathematics? Okay. Yeah. So what is average speed? So quickly think about it. What is average? Average is total of items divided by number of items. This is the basic concept. But if we have an object and it is just moving from point A to point B, again, it doesn't matter whatever path it's taking. Okay, along the way, it is, say, to a certain extent, it's moving at a speed of 30 km per hour. Remaining distance, it's moving at 80 km per hour. And the time it took over here is t1, and the time it took over here is t2. To figure out the average speed, all I have to do is figure out the total distance. How do you figure out the total distance? Divided by total time. Yeah, all this should be easy for you guys. How do you figure out the total distance for this scenario? Yes, total distance you can figure out by multiplying 30 with t1. Right, speed into time will give you distance. This is 80 into t2. And this entire thing is t1 plus t2. That's how you figure out the average speed. Okay, kind of simple and straightforward. Now, here is where the concept of derivatives and limits and comes into picture. Instantaneous. Okay, it's in the next slide. Instantaneous is the speed of an object at a very short time. So it's like averaging out a very short time. So the time is very small actually. So the idea of instantaneous, let me show this first. So this is the idea of instantaneous. Instantaneous is nothing but in a very short time, right? Something like this, in a very short time. So you can see the time or the distance between A and B is reducing. If we imagine that along the x-axis we have the time, and this is position time graph, or you can imagine this is distance time graph. The slope at a point will give you instantaneous speed. Okay, so instantaneous is very short time. So let me put it this way. So what all should I discuss? So first is instantaneous time. Okay, let me discuss here itself, I guess, or over here. Instantaneous time means what? It's just that you have delta t and limit delta t tends to 0, right? We have this, and this value is very small. This indicates very small value, very small time. Now, instantaneous. Oh yeah, I don't know why I spelled like that. Instantaneous, yeah, that's right. I never realized it, that it is T and T-N. So instantaneous speed has to do with the following. So we know that speed can be discussed as change in distance by change in time, right? So one way of thinking about this is change in distance by change in time, yes. But if the time is approaching 0, then it becomes instantaneous. Okay. So this is the basic formula. This is an instantaneous formula. Instantaneous speed formula. Another way I would want to discuss this is with, again, it is must for you guys to learn limits and derivatives before all of this. So I can also discuss it as distance at t plus h time minus distance at t, and this entire thing divided by t plus h minus t. And all of this actually, and h is approaching 0. We can discuss about instantaneous speed as this as well. Distance at t plus h minus distance at t divided by t plus h minus t. This is your first principle derivative and all of that. So with that as well, we can discuss instantaneous speed. Okay, so let me explain this with the situation. Yeah. Say we consider a time, say 3 seconds. Okay. So this is distance at 3 seconds. Now, this can be a scenario. Distance at 3 plus 0.000 many zeros and 1 second. So this is an example for instantaneous speed, say at 3. Okay, at 3 seconds. So basically here this would be 3 plus 0.000 dot 1, and this is 3. Got it? So basically h is going towards 0. This is basically your h. So this is the funda. Can you imagine this? All this should be natural to you guys, and it would be so if you have done your limits and derivatives. I think I'm done with all of it. Yeah. So we just got introduced to the idea of speed, and expanding the same idea, we have velocity, and expanding the same idea, we have acceleration. As simple as that. So speed is to do with rate of change of position of an object with time in any direction is called its speed. So we have different types of speed, and sorry, SI unit I forgot, it's meter per second. I'm sure you guys know of it. Types of speed, you have uniform speed, wherein the distance traveled by the object is equal in equal interval of time. Actually, I should be showing this as well. So let me do this. So we have a turtle, and you can see that it's covering equal distance in every second. And so we'll get a graph like something like this. So if for every 2 seconds, the distance traveled by the turtle, it will be the same. Let me show this as well. And at the bottom, you can actually also see the, let me close this. At the bottom, you can also see the velocity. You can see that the value remains the same. So let's analyze this way. I don't have space. Average speed I have. Uniform speed is what I want to discuss. Okay, I don't have space. Okay, let's have a look at this. So for that, I need to consider, say, 2 points. What am I doing? Okay. So 0 and 2. I'm considering those 2 points. Can you see that? I'm highlighting it. Now, if I happen to copy this and paste it in such a way that the first dot overlaps with the second dot, and we have the following. Okay, I'm just keep on doing this. So what is happening over here? Clearly, every 2 seconds, the distance that the object has covered is equal. We can verify this by doing this, projecting. So at 2 seconds, we have the object to be over here, around 60. At 4th second, we have the object to be around 120. Not an exact value, but yeah, it's good for discussion. This will be at around 180. Can you see that? So everywhere here, the distance, let me use this. Here, the distance covered is 60 meters every 2 seconds. and the time interval between 2 points is, 2. So this is also fixed. Every 2 seconds is what we are looking at. So every 2 seconds, we are moving a distance of 60 meters, right? So this indicates a uniform. Oh, sorry, I forgot to write the heading. This is an example of uniform speed. So non-uniform, how does it look like? We'll do that as well. Actually, this would be a bit too much. 1 minute. Let me change some values. Yeah, this would be better. Okay, let me show this. Is the object traveling equal distance in equal interval of time? Every 2 seconds, is it covering the same distance or different distance? So clearly, different distance. If this is a photo diagram of every 2 seconds or 1 second, you can see that the object is covering unequal distance in equal interval of time. And so the graph would look like this. Can you see the velocity is also increasing? Then you can see the distance time graph. You can see it's not linear. It's crooked. It's curved. So if we analyze similar manner, like we did just now, and we go consider 2 different points like this, and over here, if we try to project it, actually, I can't do this over here. So every 2 seconds, I'm considering the point and I will project it onto y-axis. See, this is a simple scenario, I know. If you're getting bored, you have to bear with this, because when I go to complicated questions, you will not get it. So at 2 seconds, this is where the object is. At 4 second, this is where the object is. At 6 second, this is where the object is. You can clearly see at 8 second, you can clearly see that the distance that the object is covering is not the same, right? If I happen to say measure, let me take this, the middle one, right? This is almost right, the distance between those two lines. So if I copy this and paste it above, clearly it is shorter. And if I paste it below, clearly is longer. Agree? So you can clearly see that it won't work out. So here we are looking at unequal distance. Unequal distance every second. I mean, this graph situation is so. So, but here we are considering every 2 seconds. The entire discussion is for every 2 seconds. So the time frame is fixed, that we're taking the same interval of time. But the distance that is covered is unequal. So that's the funda. So that is your variable speed, average speed that you guys know of. Instantaneous speed is one more thing that you have to be very clear with. And that clarity comes with your correct derivative. If you're not limits and derivative, if you're not clear with this, if you don't understand what is written over here, you won't understand the aage wala topic, guys. So you should stop, go back to limits and derivatives, come from there. Okay. Yeah, you can pause and have a look. See what you would want to add to your notes. And let me show the graph part as well. So this is to do with uniform speed. This is to do with variable speed.